Problems? Okay. Okay, no problem. So I will say, I remember, I just wanted you to, if you already have them, no issue. So I'll say the question. So this was the first question that we kind of had so we had this line. It's a line segment, okay? And sorry, the midpoint was given, right? And if I say it, you'll obviously remember. So you'll see, just see midpoint. Yes. So you see this question was there, right? We had the midpoint, this was given. Now you had an arbitrary point given. Sorry, one second, just one second. Okay, I just had food, that's why. So then we have an arbitrary point and the task is, so let's say P, okay, task is make a line, passing through P parallel to AB. So this is the construction we want to make using only straight edge. Yeah. So we only want to use the straight edge and see if we can do this. So do you have any idea? Yes, you cannot use the compass, right? But you will remember that we had done a result which is similar, which had in which this part of the configuration was there, right? We had a line and a midpoint. We kind of proved that something is the midpoint, and there was parallels involved. So can you try to connect that with this somehow? Do you see a connection? Yeah. So what do you think I should connect? Because you only have a straight edge. So what else, what we can do? Just connect things that you can connect maybe. Okay, so let's connect P and B, and also let's connect P and A and see what happens. Yeah, because if you only have a straight edge, there's not much you can do, which is maybe good. Then we know what to do. Okay. Let's see if this works. I'm not saying this will work, but let's see. So yeah, okay, we did this. Then what should we do next? So connect that with what? No, I didn't understand the last thing you said. Hmm. Okay. 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 So something. Ah. So you're saying something like Z, if I'm interpreting something like Z with B. Okay. Perfect. Okay. Now it looks more like what we had done. So I think that's going in the good direction. Let's see. Wonderful. Let me remove this PB. That doesn't seem to be useful at the moment. Or I'll not remove it because you have drawn it. So let's keep it and see. Wonderful. Let's see. We want something which is passing through P and parallel to AB. No, but you cannot measure PB. Okay. Because see, if you are measuring PB, so this is, I think it's a good point, that you can learn from here, is that if you are measuring PB, obviously, first of all, it's only a straight edge, it's not a ruler, so you cannot measure. But even if, let's say, you're not sure, you say, okay, some lines are given on the straight edge, I can measure, let's say. Do you see where the problem comes? If you're measuring PB, okay, and then you will say that I'll place it here, right? P prime. Do you see that this is exactly like using a compass? Okay. So that way also you'll see that this is certainly forbidden. It's almost like it's almost like you've thrown the compass away and you're doing the exact thing that you can do with the compass. But question shouldn't be like that, right? I mean, just and either ways you cannot measure anything. Okay, and that is, yeah, it's just a straight edge. And in fact, sometimes you cannot measure. I mean, if the length PB is pi, you can never measure that with a straight edge. You see? But you can measure that with a compass in the sense that you can copy mm, that length with a compass, but with a straight edge you cannot measure. So in fact, so in the questions you will see that they'll say straight edge, no measurement is allowed. But in fact, straight edge is useless for measurement. Okay, straight edge is only useful for measuring half and 2 and 4 and 8 and 1/10, those things. But those things are only those things. The actual things you can never measure, like pi and irrationals. Anyways, that's not important here. Let's see. Right, right. What else can we do? Yeah. So we just connect ZNM, right? Yes. So this is the rule of thumb when you're using a straight edge. Okay. So when using a straight edge, it's not that difficult to actually get the required points and lines. But to prove it, it's sometimes difficult, but we have already proved that this will work. You will see. So let me draw it with a new color because this is I think, the final thing. So we're just going to join this. So now, now no doubt this should be the parallel thing. Yeah. And you see that we have already proved this, that this is parallel. Yeah. So maybe we can call this P prime. Okay. So by earlier result, or by just an application of Shiva's theorem, whatever, right? By earlier result, or one can just prove it with geometry, is PP prime is parallel to AB. Okay. And one can also see this from the Shiva's theorem because this AM by MB, right? Again, just write this ratio. So I'm not doing it, just write this ratio and this is midpoint. So you will get that, this BP prime by P prime Z is same as AP by PZ, whatever. Okay. But we have seen that. So this is the real kind of the usage of that theorem. Okay. It implies that if you're given a line and only a midpoint and some arbitrary point, then you can actually draw a line parallel, to the original one without using a compass. It's a pretty good result, right? That we are able to do this without a compass, only by drawing lines. Okay. So let us maybe try to do one more question of this kind. Okay. So maybe I'd given a very similar question. Okay, I'd given two parallel lines and maybe asked you to make the midpoint. I'm sure you can do that now. That is just the opposite thing. But let's just, because this mostly you did on your own here. So let me just try to give a similar question. Let's see if I can make it. So this is not about drawing parallels, it's about drawing perpendiculars. Okay. But here also we will be giving something to start with. So I'm giving a circle. And let's say that this is the diameter. Is it a little low? Like this. This may be the diameter. So you see, with constructions that involve only a straight edge, some auxiliary thing is kind of given sometimes. Okay. I think it will usually be given, though. Yeah. There's a lot you can do with only a straight edge. Okay. But those will be more difficult to prove. Okay. Yeah. Yeah. Anyways, so this is the diameter and this is the center. Now, as I said, it's about drawing perpendiculars. So no, drawing perpendiculars. So we draw parallels and draw perpendiculars. So just giving a point P, I want to construct a line from P that is perpendicular to this line L, the diameter. Okay. Construct a line P perpendicular to, and obviously only with a compass. That's only with a straight edge. Let's see. So we'll see if I'll try to give some hints. I'll also think, I know this can be done, but I have not done this at least last few years. So let's see. You would want like a perpendicular. So you want a free perpendicular. A surprising perpendicular. So any ideas? Is the circle useful? Yes, it is certainly, it is essential in some sense. Yeah. Circle is very useful here. So how do you think we can start? No, but you cannot draw tangents so easily, can you? But how would you draw tangents without a compass? Uh, so yeah, because you see, tangents give you free perpendiculars. So that's maybe what you thought, right? But we cannot draw tangents. So yeah, so you can either try to think like, how do perpendiculars arise, right triangles arise in circles? Or you could just go with the earlier scheme, maybe of just joining lines with whatever points is available to you, right? And just joining the new intersections and so on, and eventually you get something. I mean, that's usually how straight edge constructions are. But let's see. So there are two kinds of things. You can see which one, how combine them out. So like, what are the points that we have? Right? You can think. So if you have the point P, certainly, and if we have the point O, and we also have like this intersection point here and this intersection point here, right? And we have the point O. So there are these 4 points. So we can try to maybe get started with joining some of them and so on. So you can think, or if you're thinking about some other direction, you can see. So how about if I just draw some of them, right? Let's see. So if I join this B and this B, is this line visible or is it too thin? Visible. Okay, because I'm not trying to draw everything with the same thing, right? Because not be it's another same importance maybe. Okay, this one line, this is one of the lines you draw naturally, right? And then you see you get this you get this new intersection point. Sorry, you get this new intersection point. Do you see any perpendiculars arising already? Some right angles, perpendiculars somewhere. Let me call this C. Not, I don't know if BC is the hypotenuse, but B? Yeah, BC may not be. I mean, eventually we would want maybe BP to be the hypotenuse, but right now BC is not necessarily the hypotenuse. But okay, so maybe you have not done this result. Okay, you will tell me if you have not. Then I don't know, and then I'll just discuss that. I don't know if you have done it or not. Do you know this, that BCA is going to be 90 degrees? I mean, if you didn't know that, then it's unfair to ask this question, I think. Ah, okay, okay. Uh, but maybe you will be doing it soon if you have not seen it in the school, right? It should be there in the NCRT, but either way, that's not the point here. Point is that it's a very straightforward result. I mean, we can just prove it in 2 minutes. And it's also like, it looks correct also. And this is the natural way in which right angles come in a circle. Okay? So if you have a circle and if you have this 90 degrees, this is diameter, then any angle you draw, that's the magic. Any angle you draw, means any triangle you draw, you know, with all three on the, with the third vertex also on the circumference, then it will be 90 degrees. Whatever ABC there. Right, this will be 90 degrees. So let me not prove it for you now. You can try to prove this on your own. Okay. Try. I mean, this is a standard result. I mean, just see. It will be. This is a. But it's not a. It's not a extraordinary. Like it's not something magical. It's look correct. Okay, so that's how you get your first 90 degree. You get your first right angle triangle, like a naturally occurring right angle triangle. Okay. So then how can we use that? But please, like next time, so just try to prove this, okay? Next time I will discuss this. And there are some extensions of this which will be very useful. So we'll discuss it next time. So you have your first 90 degrees. Now what should we do? I mean, so what I will do is I will just, again, just arbitrarily join the lines, right? I'll join P with O, right? But I don't have, I mean, what else can I do? I join P with O. I join P with A. These are points I have, right? Now you can think if there's something interesting in this. Because I only have a straight edge, so I join things, new points that I have, the old points I'll join. So do you see another right angle triangle? E. So what is the E? Did you say E? Oh yes, PAC. Oh, yeah, that's obviously right angle. Yeah, that's right angle certainly. That's true. But there's another one, right? If we mark this thing D, just by the same thing, right? So let me join that. So you may see where this is going. The altitudes of a triangle are concurrent. We already have two altitudes. Kind of want the third one. Okay. So we do this stepwise because this problem directly is a little difficult. Okay. Kind of breaking it into steps and doing it. You get these two right angles. I'm just removing this one. This one doesn't seem to be useful. Now you can think. So now you have some new points and new lines. So you can try to find new intersections. That is always the goal, always the strategy, you could say, the go-to thing in this constructions. Like you have this. So what are the new lines you drew, right? We have drawn CA, we have drawn BD, and we also obviously have BC and we have DA, right? BC and DA we have already joined. Okay. I mean, we could join, for example, CD and AB, but that this point seems a little arbitrary, but still you can join them. But there are other things which you can join, right? So there is CA and BD and so on. So always when you have new lines, segments, just segments drawn somehow by intersections, just extend them and you get new intersections, right? And so on. One of those intersections is going to give me the answer. So the question is, how to find new intersections? See, we are not going to, if we want the perpendicular from P to L, right? We cannot directly find the perpendicular. We cannot directly find the foot of the perpendicular. That's almost impossible. Okay. We will have to find some other point, right? Such that, that point joined with will be the perpendicular to L. And that will come out as intersections or something. So we need to keep trying to find new intersections from what we already have. Right. Okay. Yeah. So you will see with what we have, I mean, isn't like joining CA and BD, trying to extend CA and BD, the only way to kind of get a new intersection? Right? Do you agree? Yeah. Now this may be a little, okay, I'm extending the line, but there is no other way, right? Kind of to get new intersections. Right? Obviously, now you can get OC, you have OC and BD, but these don't seem to be, at least you can tell me, these don't seem to be very interesting. Okay. Yeah. I mean, obviously, some things you have to just go with what looks correct and so on. And then obviously there's BD. You want something like this. Now you tell me something looks to have something looks like has happening. Uh, yes, exactly. This is the thing. See, this is a scheme that we are using, and it's kind of helping us. Okay, just joining the new lines and new lines, and obviously we with some sense of, we can't just join all possible things with some sense, and we are kind of getting there. It's nothing magical, right? We're just doing the same policy again and again, repeating it. And this certainly looks to be perpendicular. Now, let me just join it, and then you try to prove why it is perpendicular. So there's no doubt that this is the answer. Okay, this is 100% sure. Almost. How do we prove it? How do we show this from what we know? Let me not just put it like this. bx. So show that bx is perpendicular to px or pq. So remember, this bx is the line that is passing through b, o, and a. It is passing through a. A is a special point now. I think I'll just see if I can bring out some things. I wanted to do a problem which involved some calculations. Let's see. Any ideas how we can show that that is also 90 degrees? Okay, no ideas. Let me clean up the picture a little bit. Okay, I'll remove the circle, remove this line, remove these things which are not important. Now you will see, you'll get some clarity. This looks like a very familiar thing now. So what would you say to prove it? That will prove it. Because now it's a game of altitudes. No. Why should dx be parallel to bp? No, so c is not the midpoint. C is not the midpoint, right? Yeah. In this picture, it is not. But you can see that CQ is an altitude, PD is an altitude. So the third line that is passing from the third vertex, so to this has to also be the altitude. Right. But then how do you say it from a theorem or from a result? Like, what do you say? What do you have? What am I using when I say that bx should also be the altitude? That has to be framed, right? It should be, but it is not easy to prove, right? So it's not easy to prove, but then we can just say a theorem and we can kind of, we'll see. So since bx, sorry, not bx, since CQ and PD are altitudes, okay, B BA BX passing through the intersections of CQ and PD is also an altitude. Right? Why? Because all three altitudes are concurrent. Right? Because all three altitudes. Now we have not proved this, but this is the, I mean, one should prove it, but I mean, we can use this. It's not a problem because all three altitudes are concurrent. Okay, so all three altitudes are concurrent. So if this one is not the altitude, okay, then how will it work, right? Because then there is something else which is the altitude, but then that cannot be concurrent. You can say it in any way you want, right? But because there's only one perpendicular you can draw, or, yeah, you can say it in any way. But so we are using the fact that all three altitudes pass through the same point. Okay, so you see there's a very close connection with these two kinds of questions. One is that when you're constructing things using only straight edge, you are kind of having these theorems about you kind of needing these theorems about concurrency or ratios, and we have seen there the connection there also, right? Concurrencies and ratios. I've already seen some theorems. Okay, so this go hand in hand. So now the job is to try to prove that three altitudes are concurrent. Okay, so this is the connections between these things. So that will be the thing maybe you can try to do, but let us not get into this immediately. Let us maybe try to do some other questions we had last time. Okay, now there are more constructions which one can do without a compass, some new kinds of constructions, but they will be a little advanced, so let's not go into them. But you can see the kind of question that I'm asking, the fundamental question that is behind all this is how much can be done using only a straight edge. Do you agree? Like this is the fundamental question which we're trying to answer. Okay. But every time we had a construction, we kind of had some auxiliary things. Okay. We kind of once we had like once we, it's like the last question was like you could use a compass only once. Right. I mean, that's how I could have made the question, right? That given a point and a line, and you can use the compass only once, drop a perpendicular. That's what the question was. Using the compass only one, you can only draw a circle, and now you drop a perpendicular, right? So that was so there's a game is like a little bit you can restrictions with that, and you can play with that. And why am I starting with perpendiculars and parallels? Because to any general construction, these are the fundamentals. You can build any construction out of parallels and perpendiculars and midpoints and go on. So these things will eventually allow you, not now, those are very mature theorems, will allow you to show that anything that can be done with a compass and a straight edge can be done by using only a straight edge and a compass only once. Okay, so anything that can be done with a straight edge. So given a straight edge and given a circle drawn to you, and with the, okay, just a second, parameter, circle with center given. I mean, center can also be, I think, found, but let's just put it like this. Circle is given, center is given, okay? And a straight edge is given. Using these three things, you can draw anything, you can do anything that you can do with a compass. Okay, but that's a big theorem. We cannot prove now. Okay, so that's a culmination of these things where it goes. Okay, and then there are other things like what can you do with only a compass? That's another type of things. Okay, and there are also theorem there. Okay, that using a compass, you can do anything that you can do with a straight edge with some small condition. Okay, so those are very interesting questions. And then there are questions like what can you not do with a straight edge and a compass, both given, like constructing cube root of 3. You cannot construct, but those go into some other kinds of things. So it's a very deep questions and very old questions. Okay, so yeah, that's the fundamentals. Let me just think. I think I can ask one more interesting question, which is very elementary. You won't need anything for it apart from what we have done. And I have thought about doing this. This is a very good question. So let's do this one more question. And this is about drawing tilings. Okay, drawing tilings of a floor. Yeah, this is also easy. Easy in the sense that it's in the reach for us. It's not easy. Let's see. Drawing tilings of a floor. Okay. All this is connected with other questions I had asked about ratios and so on. But let's see. So let's say that we have a flooring and we have kind of taken, so we have this flooring, okay? And we took a picture of this. So it's like, it's like this is the flooring and I've taken a picture right from the top. Okay, the square flooring, but I've taken a picture vertically from the top. Then the picture will look like what I've drawn. Yeah, do you agree? Yeah, but if I take the picture from different angles, if I take the picture from this angle, then the tiling would look very different. They would look like diamond shaped things, and a strange perspective will be, you can kind of see, right? But I'm not going into those things. Those are actually not harder. These are also hard. That is also hard. Those look hard, but they're actually easier. Okay, but let's try to do this one. The question is this: if someone gave you one square in a square tiling, can you give them the entire tiling using only a straight edge? Okay, so I've given you one square, that's all, and then you have a straight edge. You don't have a compass. Is it possible for you to draw the other squares? And you know what it means. Right? So complete the tiling. Basically, I just want you to draw one more square. The very easy thing. Let's see. Okay, complete the tiling using only a straight edge. Obviously, that's already given, so I'll just say complete tiling. Just think I'll plug in the charger. Battery is down. So you have the square, meaning that you can obviously extend the lines that you have. That is certainly what you can do with a straight edge. Yes, yes. Like we want the square tilings, and if one is square tiling, everything should be identical. So it's like we already have some parallels given, and you want some midpoints. If you want to think like that technically, otherwise, it's just freely you can think, and will naturally come maybe. So you can obviously, what you have, you can use. I mean, how much we are able to do with only a straight edge is saying something very fundamental about the nature of lines and points, right? That there are always coincidences. Even you have arbitrary set of lines and points, you always have some strange ratios coming up. That is what this your power of straight edge tells you about the fundamental nature of lines and points in a plane. Yeah. So that's, so you can use these things. I don't know if they are useful. All of them are useful or not. So they certainly have to be identical. Mm-hmm. Hmm. Yeah, something. Let's see. So diagonally, you mean join AC and BD. Okay. So let's do it. No, let's do it like this. So we join AC and BD. Yeah. So, but that is the midpoint of what? So it's like we have the midpoint, but then we don't have the line whose midpoint it is. But this is certainly a first step, because what else can we do? There's nothing much we can do. Okay. Yeah. So I mean, obviously, I think this is what you meant. I didn't understand that time. O is the midpoint of DB, and O is also the midpoint of CA. So we certainly have that. Yeah. So you can use that, because we have proved things and so on. So you can use that. You can also think backwards. You can assume that kind of you have a point here. Means if there was a point here, which is, that other vertex of the square, then what would its relations be with the other ones, other things? Then maybe you can make one of those things working backwards. Yeah, so that's what we have to kind of do, right? But we can't do that directly because we cannot measure the length, right? But we can study the properties of x. Let's see, this x is this. If you join this x with b, like if you found that x, right, then that x is will be such that x is such that it will be parallel to AC, right? So now you know what to do. Now you would want to make a parallel, something that is parallel to AC passing through B, isn't it? That's how you'll get the X. But you can do that. You know how to do that, right? Because you see, the problem is the old problem for us now. Because B is a point, okay? B is a point, AC is a line, O is the midpoint. So you can make a line which is parallel to AC through B. You know how to do that. Right. Now, this is not the only way to do. Someone who doesn't know this result can do this in a different way. So you have to think. But this will also do it. Okay, this will certainly do it. There's no doubt. It's a rather quick proof. Okay, it's a quick proof because we knew a lemma. I remember this was like there was an advertisement for a course, some advanced geometry course, some projective geometry course, and this is like just like a puzzle to get people interested. Okay, and the professor had started with this question. Okay, obviously he did it in a more complicated way because he didn't assume this result. Okay, but obviously we have done it. So, but you can do it in many other ways. You can think. Okay, the idea is that when you see, if you are stuck, obviously let's forget that we have done the problem. Let's say we didn't know this result. Okay, the idea is you can still proceed. See, when you do not know anything, do not have anything, what can you do in a compass? You can just take an arbitrary point and get going. Isn't it correct, right? Take an arbitrary point and get going. Take an arbitrary point, join some things, or just get going with something like that. Or just take an arbitrary point on one of the lines that's not so arbitrary, and then just get going somehow. Or do something. I don't know, right? And find something. It can be done like that also. Okay, but you have to just do a little bit more work. Okay. Yeah, but obviously we had this, so we are able to do it. Good. Okay. So let's stop here because I'll also take a class tomorrow, I think, but that's a scheduled day, so we should do that. But and I'm not giving any too many homeworks today because we already have problems from last time. So this was good, right? But now I would like to just give you one problem to think about. Maybe is now if you look at the tiling from a perspective, okay, so there is some perspective from which the picture was clicked, and let's say the tiling ended up looking like this. You agree that it is possible? Yeah, some perspective. So roughly, so maybe it was like this, and if you view it like from here, maybe, right? Yeah, if you view it somewhat from here, then this will appear like this. Okay, You can imagine that, right? Now it looks harder, but in fact it's easier. But anyways, we will see. Now what I want you to do is complete the tiling. If this is one tile, if this is how the tile looks from this perspective, then how will the other tiles look like? Okay, but you have to keep in mind that it is the perspective of this square tile only that you know. And now you want to complete the tiling. So two things, okay? The tiling is not actually whatever that means, okay? It's not actually this, okay? This is what we have drawn after taking a picture of the tiling from a certain perspective. The tiling was this only, and with other things, other squares, okay? They're all identical, obviously, all identical and so on. So there was a square tiling only, and its picture you have taken from some perspective so that this came out. One of the tilings came out like this. If one tiling came out like this, then how would the other tilings look like? Okay. So just think, yeah, this maybe, I don't know, you can get started, but you didn't think. You can just think, okay? This is not even a homework or something. This is just think about. Okay. Yeah, because it may be a little different. But I don't want to introduce this concept now. This is just today. You will notice that there are many problems I have asked which I have not discussed. Okay, because they are a little hard. We will come back to them later, or you yourself should come back to them later when you have more knowledge. There are many things, right? Many problems which I have not discussed, right? After, but those are for you. Those are for you to discover in the future, maybe after 4 months, 5 months, or even after a year, when you suddenly do it and you'll just click. Okay, so just keep them in mind, keep trying them, think about them. That's how you will learn and connect things.